So there's no short response. It's just actually there are some short responses. There are some short responses. I don't have past midterms. I would speak to your lab professor if you have a conflict. Yeah, if you have a conflict, speak with your lab professor or Dr. Waxman directly. Again, the exam is supposedly this Monday. No, there aren't. From what I remember, there aren't any multiple choice with Dr. Waxman. Okay, no problem. I don't have that physical paper because he doesn't give it back to us. What I can do is give you what I remember from mine. Yeah, Mike, thank you for sending. Is it better now with the static? Okay, perfect. Okay. Sorry about that. Okay, so let me share my screen really quickly, and I will. Okay, you guys can see my screen, correct? Okay.
Yeah.
Perfect. Okay. Okay, fine. So this is what I remember from my midterm. There was the first, and it was about while loops. So I'll give you guys the example that I had. His goal is to make you understand what's happening in the code. Okay, somebody also said stable marriage. And 8 members in a cross. What else is there? Let's see. Do you have to manually write out
Could
the
you also go over pointers and specifically pointer arrays?
yes, pointers slash arrays. Okay. And there was an example of this in your booklet in your class notes. So I'll try to find it in mine. There was one question about 8 numbers in a cross, and definitely one about pointers. While loop had 3 parts to it. There was also fill in the blank with 8 queens, 2D go-tos. And I'll go over that. Stable marriage wasn't on my midterm, and it wasn't on the last semester's midterm. But yeah, this specific one was with the helper array. Helper array. Okay, so let's go over the while loops first, and then we'll touch base on everything else. So, no, I think I know what you're talking about. The cannibals and the like 2 groups, cannibals and something else. How much is the fill in?
Could you also like go over brute force?
What do you mean by brute force?
I think those were like okay functions.
For 8 queens?
Yeah.
Yeah, if we have time, I will for sure. 8 queens. That was a bunch of for loops within one another, right?
Yeah, yeah.
Okay.
Kind of confused. Yeah.
No problem. Okay, how much is the fill in? Like I have to write the entire main. I'm not 100% sure what you're saying, Leo. Can you rewrite it for me? The recording is on the QC Learning Commons website. It's not going to be uploaded to Brightspace. No. Mike can put. I think Mike already did, but Mike, if you can, yeah, thank you. That's where it's going to be found. Okay. Let's do the while loops example. So he's gonna give you part A, B, and C. Let's say we'll do part A first. So we'll say this while, and then let's see if I remember it. It was while I is less than 10, and we'll assume that we said int I equals 0, while I is less than 10. C out I. Okay, something like that. So you're going to say, what's the answer? He's going to ask you for the output.
কি হয়া?
Sorry, while I is less than 10. Here we have to do and then I plus plus. Okay, so somebody in the chat, let me open up the chat again. Tell me what the answer is for this one specifically. And then there's also an explain part. Sorry, not just an answer, but answer and explain. Good, perfect. So those two answers, error because of infinite loop. Excellent. So just to go over this part over here will keep going. This second line will keep going because I right now has the value of 0. I never do anything here to change the value of I. So it's going to keep going. It's going to say while this line, this is true. Because it's true, we do it again. And it's going to be true again and again and again. And that's what gets us that infinite loop. So we get an error. Nothing gets printed out. Okay, does that make sense so far? Okay, perfect. The second one was a different variation of this. And it was part B. We say, let me do it in black. We say int I equals 0 while I is less than 10. I plus plus C out I end up. So again, answer and explain what the answer to this will be. So I'll put, yeah. So a lot of the questions he puts, they're not particularly hard if you look at them correctly. So I'll give you another example from something that I remember seeing. Can we get the recording afterwards or no? Again, yeah, the recording is going to be placed on the Queen's College Learning Commons website. Will the review be uploaded? It should be uploaded by the end of the day. If not, at latest tomorrow morning. 10, 10, 10, 0 to 9, ROM 10, no semicolon, thing 1 through 10, 10, 10. Okay, so let's go through this because prints 0, 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, so I said 9, 2. Okay, let's see what this prints out. So we're going to do the work here. I is 0, okay? I go through the loop. I check. So this is, we'll call this line 1, 2, 3, and 4. Okay, we did line 1, I is 0. Line 2 is true, right? 0 is less than 10. Great. So I do I plus plus, I is now 1. And now I don't go to line 4 yet because I'm still in my while loop. So now this is the first one. Then I do it again. I say I equals 1 now. I got that from here. It's still true. 1 is less than 10. Sorry. 1 is less than 10. And now I increment, so I is 2. Now I is 2, it's true, I is 3. And we do that until we get I equals 9. This is still true. And then I is now 10. Now we have I being 10. It's false. 10 is not less than 10. Remember, 10 is not less than 10. So we don't even move on. We leave the while loop. And we go to our fourth step, where we see out I. So we print 10. So here it's 10 because the while loop increments the value first, and when the condition is false, we print the value of I. Okay, does that make sense to everyone?
Yep.
Great. Okay, perfect. And now, the fourth.
Yeah, I actually thought, I'm sorry, like I actually thought that it's gonna print like from 1, 2, 3 up till like 9.
Oh, up to 9. Okay, I see what you're saying. Okay. But yeah, so these are just some of the tricky questions that Waxman can put on the midterm that many of the students do just so happen to fall for. So just be careful of where a semicolon is placed, so things like that. Let's do the last one. C. Okay. Again, we're doing int I equals 0. While. And just so you guys know, some questions, for example, in this question, if he'll say, there could be a pointers question. Let's say a pointers question where there's part A and B. A says, A asks rather, what is the answer? And B says, what is the reason? Why is that the answer, for example? And then he'll put a little note at the bottom saying, if you get part B wrong, the entire question is wrong. So he has some questions in the midterm that if the explanation is wrong, he's not giving you credit, even if you got this part correct. Right here. Even if this is correct and this is wrong, the entire thing is wrong. You get 0 points. Okay. So we're gonna go over that, Carl. Yeah, he wants to make sure that, at least I'm assuming that nobody's copying off of the person next to them because he doesn't make different versions of the midterm. So here we do I++, and then we say C out, I, and L. Yep. Okay. What's the answer? Gonna be here. And be very specific with it, by the way. Not super accurate. You don't have to give like an entire paragraph, but it just has to show that you understand what's going on. Meaning if you give the answer, if you give the explanation because that's what the code does, and you don't explain what the code does, then you're not going to get credit for it. But if you somewhat explain to it, you can argue a little bit for the credit. Excellent. 1 through 10. All right, 1 through. Let's actually run through this really quickly. Okay, so yeah, it should be 1 through 10. Correct. Good. So if you said 1 through 10, you are correct. And let's see why. We start with I being 0, right? So, but I automatically increment first. If it goes true, I increment and then I print. So it prints out 1. Then 1 is still less than 10. I increment, it's 2, and I print it on a new line. That's what end down means, on a new line. And then I do 3, 4, 5, 6, 7, 7, 8, 9. Now I is 9. We've established I is 9 because I printed it out here. So I check, is 9 less than 10? And that's true. So I increment, I goes from 9 to 10. And I print it out here, 10. Then I say, okay, I is 10. Is 10 less than 10? The answer is no. So we leave our while loop and go to whatever else is in the code. Excellent, John. You explained it perfectly. Good. So this is going to be our answer, and you can put a little explanation. We increment first and then print out the value. We use values 0 through 9, which means it prints out values 1 through 10 if we're incrementing first. But again, Professor Waxman can change it up. He can give you something like this. Int I equals 7, while I is less than or equal to 18. And then he'll say, see out I on a new line, and then do I plus plus. Something like that, which means the answer would be entirely different. For this question, I don't remember there being a part for you to explain, but if you have to explain, then the question is generally worth more because he cares more about the way you understand the question and less about the answer. So, okay, good so far with the explanation. If you're bad at explaining, I would say still, or give an example. Give another example that you can on the midterm. Just try to show, because remember, the lab professors are the ones grading it. How they do it is there are usually 10 to 12 questions on the midterm. Each lab professor will take 1 or 2 questions and is grading it for every single lab section. So it's not your lab professor grading your entire test. It's your lab professor grades 1 question for all 300 or 400 kids who are taking this test. So they have to be really fair with it. Do we need to every answer? Only when he asks. Only when he asks, give an explanation. And Professor Waxman will also be in the room if you guys have any questions for him specifically. Okay, here's an example of something that Waxman will trick you with, or could trick you with, rather. Let me see if he'll say, with pointers, he'll say int g. Well, first, actually, you know what? Let's go over pointers really quick. Just the basics of pointers, then we'll go into the arrays. How do I declare a pointer? So a pointer is a variable, just to remind you all, a variable whose value is an address. Okay, that's really it. Addresses are in hexadecimal form, which if you didn't take CS240, you don't have to worry about. Declaring a pointer, we say the data type, and then we use a star and the variable name. Okay, so an example, we say int star h. Okay, int star shows me that it's a pointer of integer value, and h is the pointer's name. Okay, initializing it, I have to give it an address. So it would be int star h equals and x. So and ampersand rather, ampersand means address of. So the address of X. And now the star means three things in computer science. Do you guys remember what it means?
Multiply or dereference.
Good. And then the last one, initializing or declaring a pointer. Good. So he could give you a question where he gives you functions with pointers, because I think he spoke about how pointers, or rather how in C++, arrays are just syntactic sugar for pointers, meaning their base is built upon the pointers. So he might give you a question with which he does on the final, where you have to figure out when you're multiplying, when you're dereferencing, and when you're declaring a pointer. So one way, declaring a pointer has to have a data type next to it. Multiplying is usually with two numbers. And then dereferencing is if you have a pointer with a value of an address already, and you want to get the address, you want to get that address, that's what dereferencing is. Once it's initialized as, to refer to it as variable h, as variable h. You only refer to it as variable h. Okay, so here's an example of something that Professor Waxman has given me in the past. Int h equals 3 star p equals ampersand h. So this says p is a pointer with the address of h. Okay. Then I say here, I say g equals g divided by, or rather g slash p. And then I'm going to put a little comment here that says dereference integer pointer p. And then I see out g. And so now he asks you three questions, or I think it's three questions, right? The programmer expected that this program will print a 3. Okay, so now his exact question says explain exactly why. Okay, and he says in parentheses, a diagram may help. So let me show you to you again. Do you know why he would say, why the programmer would think that 3 is printed out? Does anybody have an idea? Because pointer p has the address of h, because g is 9. Okay, Hamid, you're the closest. So what he's getting at is when I want to print out g, I have to look at where the value of g is last modified, which is the line right above it. So essentially what he's saying is dereference p. P is the address of h, so p equals 0 ex f f h 6 1, whatever, that's an address. Dereferencing this gives me the value at that address, which is 3. So star p is 3. G was originally given the value of 9, so good, 9 divided by 3, the whole thing needs to equal 3, right? So That's why the programmer expected 3, because 9 is divided by the dereferenced value of the pointer, which is 3. And then you say 9 divided by 3 equals 3. Okay, perfect. Now his second question says, however, the answer is really 9. Okay. Explain exactly why. Okay. Do you need to specifically dereference when wording? Yes. That's an important portion, because then he's going to ask you, how did you get 9 divided by 3? He understands that the G is 9, but how did you get star P to be 3? He wants you to say that you're dereferencing the value of the pointer, which is the value of the address. Scroll to. Can you? Do you guys want me to scroll up or down? Oh, just to A. Okay. Here, let me make it a little smaller. Okay. Yes, correct. In this case, star P means dereference. Remember, it can't be multiplying here, and it can't be declaring a pointer because there's no data type in front of it, so it has to be dereferencing. Okay, so does anybody know why we actually print out 9? And this is where he tricks you. And I think somebody actually said it before. What about that, Azam? You're close. Correct. Who is that? Aryan. Good, Azam. So what does it make it? Excellent, good. It turns it into a comment. This whole part, starting from the first slash star up until the closing slash star, is a comment. This whole thing is not read by the compiler, which is why I made this semicolon bigger. Okay, so really all the computer says is G equals G, and we established that G equals 9 over here. So we just say something similar, because the and turn everything into a comment, which means the compiler only reads G equals G. And then you can say, since G equals 9, we say G equals 9 again. That's it. Yeah, the parentheses were not there before. I added them throughout. I can take it out also. The parentheses were not there before. So to fix that, you would do exactly, Marjan. You would put the parentheses here, and then you would have to put the parentheses here, and then you would have to take away this semicolon, this second semicolon, because this semicolon would count now. Okay. Now I just remembered another question he asked. This was the second question on our midterm. I forgot how he phrased it, but I remember the question. He says this. He says, so everybody knows that ampersand means getting the address of a variable, correct? Or at least they do now. Perfect. So if I give you something like this, I say int x equals 5, int star ptrx equals ampersand x, okay? Can I say ampersand x? Explain. Okay, so the answer, I'll give you the answer. The answer isn't so important. Remember, the explanation is what's more important here. The answer is no, you can't do it. The question is, why can't you do it? Exactly. There can't be two addresses to one variable, right? You can't take the address of an address. That's exactly what it is. So you cannot take the address of an address. Think about it like this. You ask your friend what is their address, and they tell you 123 Main Street. You say, okay, what's the address of 123 Main Street? That doesn't make sense because 123 Main Street is the address. How about ampersand P? Yes, you can say ampersand P because pointers also have addresses themselves. They are variables, so they have addresses. Pointers are still stored. Question, if you did run, I'm not sure what would happen. You might get a segmentation fault. You might potentially, I mean, you can always run it. I'm not sure what would happen. Good, okay. So this right here would be enough to give you full credit on that question. No, you cannot take the address of an address. That's it. Any questions so far about that? So, Adarsh, and x is the address of x. Okay? And x is the address of x. If I say, and then ptrx is also the address of x. If I do star ptrx, it would be the value of x because I'm dereferencing. And if I do and ptrx, ampersand ptrx, it's the address of ptrx. Because remember, pointers also have addresses. Why wouldn't it simply return the same thing? Which one are you talking about, Joel? How do you know if a pointer is being used to multiply? I don't think you guys learn pointer multiplication, so that shouldn't be a question on your midterm. Are you able to dereference then take an address? If you're talking about the same variable, then yeah, you can dereference and then take the same address, but that would be redundant. You would be saying, for example, you would take the address, say PTRX equals that. You say star PTRX, and then you say star PTRX, whatever, and then you say and X again, if I understand your question correctly. Like, why not just return and X? So the issue is within the compiler, you can't do this. Syntactically, taking the address of an address doesn't work. Just because the address is more of name and it doesn't have. Okay, can you go over this or something similar? I can try. Correct, both, because remember, what is a pointer? PTR is short for pointer. X is just the variable. So pointer of X. A pointer, remember we talked about it before, is a variable. All variables have addresses because they have to be stored somewhere. So it's a variable with an address, with a value of an address. Let me see this question somebody sent in. I'm going to try. Yeah, this is pointer with arrays. I'm going to go over that soon. Okay, but does anybody have any other questions about this type? Okay, so let's move on. We'll do, he did give us, see the other questions. He gave us 8 numbers and a cross. Okay, that one's pretty simple, straightforward. So the goal of 8 numbers and a cross I did this correctly, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. The goal of this. Okay, the goal of this is to make sure no 2 neighbors, which means adjacent and diagonal. Adjacent means next to. Adjacent or diagonal are one value away from each other. Okay? So he can label this array however he wants. So I'll do that too, and then we'll work on it together. So we'll say this is 7, this is 0, this is 3, this is 4, this is 2, this is 5, 6, and I'm missing 1. 0, 1, 2, 3, 4, 5, 6, 7. Excellent. Okay, so you create an array, and we'll call it array A. Okay, so it's going to be a 2D array. We're going to have a helper, okay? Rather, it shouldn't be that big. Okay, so is there going to be a part where we have to create? Yes, that's the question. That's for 8 numbers and across. That's the question that you guys will be seeing on the midterm if he keeps it the same. Okay, it will be create a helper array. He's going to give it to you however he wants, and you guys have to find the neighbors. So we start at 0. We start right here, where I put an X. And now the question is, which neighbors do I have to be careful of? So somebody in the chat, tell me, which neighbors do I have to be careful of?
None.
Exactly, none. So we'll put a sentinel, -1. Okay. Now, so that one's all clear. Let's go to 1. Which one do I have to be careful of?
None.
None, again, right? Because remember, at 1, none of the neighbors, adjacent or diagonal, have been dealt with. They don't have a value, so I don't have to worry about them. Okay, so that one's all good. Let's go to 2. At 2, which one do I have to worry about? So
0 and 1.
0 and 1. Excellent, good. So 0, 1, and then we put our sentinel, negative 1. Okay, good. So now we finish with 2. Let's do 3. Which one do I have to worry about? 0, 1, negative 1. Excellent. 0, 1, negative 1. Perfect. Let's do number 4. Which one do I have to worry about? 0 and then negative 1. Good. So we're checking for which neighbors are we. So if I'm working on box number 4, which neighbors do I have to make sure the value is not 1 more or 1 less than? So with number 4, the only neighbor that's next to it that has a value so far is box number 0. 7 does not have a value yet, and 6 does not have a value yet. So I don't have to worry about those. Okay, with number 5, we'll do number 5 slower. So number 5, black X. Which neighbors do I have to worry about? So with number 5, I have to worry about the neighbors that already have a value. That's 1, that's 2, that's 0, and that's 3. Okay, I have to worry about those specific neighbors because they are the ones adjacent to it, which means horizontally next to it on the left and on the right, and up or down, vertically on top and on bottom, and then diagonally there are none. 6 and 7 are not yet with values. So with this one, I say 0, 1, 2, 3, then negative 1. Somebody asked me about the sentinel. Yes, by the way, writing it in increasing order, you have to do that. He specifies that on the midterm. If you don't, he said you don't get credit for it. Somebody asked me about the sentinel. Your sentinel can be 100, 1000, 75, whatever it is. This is how my lab professor explained it. It could be -1, -2. The idea is that it just needs to fit. Sentinel is a stop number, exactly. It just needs to make sure that it would be an out of bound issue. So, for example, you would probably be doing this in a while loop, right? I believe the OK function was a while loop, and you say while a sub something does not equal, and you can say -75, for example. But then you would have to change all of these to -75 if you wanted to do that. But I suggest that on the midterm, you just stay safe and use the -1. Oh, so any number before 0 and after 7. Perfect. Exactly. Yeah. Good. Okay. Actually, I think for the values inside, he wants you to do values 1 through 8, not 0 through 7. So any value below 1 and above 8. Okay, so we just did number 5. Let's do number 6. Which neighbors are around number 6 that already have a value? 0, 2, good. 4 and 5. Good. So you have to remember, you have to write them in increasing order. 4, 0, 5, 2 wouldn't get you credit for it. 0, 2, 4, 5. And don't forget the sentinel of -1. Good. And then the last one, 7. 0, 3, 4, 5, -1. Excellent. Good. So we see this is of 8, 5. And then we just close it one more time there. Okay, good. So this is an exact, this would be your answer to the helper array. I think it's worth 15 points. There's no explanation needed. Nothing. It's just write this answer and you should be fine. Okay? Any questions regarding this? Helper array, how we got any one of the rows, and what 8 numbers in a cross would do. No, I don't think so, but all the OK functions are very similar. They have the tests within them. He doesn't care if you add a comma each. Oh, actually, you're right. I don't think he'll particularly care about that, but I should put this and then you are correct. So this is, remember, this is the rows and this is the columns. Because we have 8 rows, 1, 2, 3, 4, 5, 6, 7, 8, and 5 columns. 0, 1, 2, 3. Well, I started from 0, but 1, 2, 3, 4, 5, like that. Will there be a separate explanation? No. From what I remember, there's no separate explanation. I want to take the chance. Do we need to know how to write backtrack? In the go-to, he didn't make us do it. Can you show us how to do the inverse? Use the helper array to label the boxes. Okay, that one might be a little bit more challenging. We can do it for sure. Yeah, but it's just going to be trial and error. If we have time, we can do it for sure. Another question I remember him asking us was write the OK function for 8 queens, 1D, no go-tos. Okay? Does anybody... Oh, yeah, he will leave. Yeah, there. If I remember correctly, there's one question about go-tos, which I'll go over right after this. But write the OK function for 8 queens, 1D, no go-tos. Just the Boolean function. So you have to write the title line, which is Boolean OK. You take in the array into Q, and then I believe the column you're currently at. And so we want to check 2 things. We want to check the row and the up and down diagonal test. But the up and down diagonal test, if you use the absolute value, should get you the same. No, you don't need that. You don't need the hashtag include iostream. It's the for loop. Yeah, it's the for loop. Good. So there's going to be one single for loop. I is going to be less than the column, and we're incrementing I. Okay. So does anybody remember how this one looks? Good. So that's the row test. If Q sub I equals Q sub C, return false. Let me go through my notes and see if I have it, because I remember him giving it to us. And then, okay, page 43. Let me see. Boolean. There it is. Perfect. Thank you, Nicholas. And Joel. Great. So it's 2 things. We're checking the rows. So Q sub I equals any value up until the column, And the reason we do absolute values because when we do subtraction, we get either 1 or -1, but we don't want to write it twice. We want to just write it once to be as efficient as possible. If it falls into any one of these categories, this is what we call the row test. And I'm just going to combine this and say diagonal test. Okay. Then we return false. Now, closing this off, this and this. If we're out of the for loop and we didn't return false yet, we return true. And that's it. Perfect. Excellent. This, very simple. It's 4 lines of code. The title line and then 3 lines of code. Very simple to remember, in my opinion, but there's a lot of memory for his test. So if you just remember this portion, I think this was worth 10 points. Okay, and he also gives you 15 points. 15 questions. So you can get over 100, which a lot of kids have. They did get over 100. And his curve depends on how well the class does. If the class does relatively well, it's square root times 10. If the class didn't do so good, then it's square root times 11, 12, or 13, depending on how poorly everybody did. The parentheses after return true closes the bool okay. You mean these braces? Yeah, that would close it. Oh, so you're allowed to answer over 10, or you can answer as many questions or as little questions as you want. But once you get 100, if you get 152, it just counts as 100. He's not going to give you 152. No. If he gives you 15 questions, you can choose to answer all 15 questions. And if you have time, I would suggest you do it. I would suggest you try to do as many questions and don't leave anything blank, so that way lab professors can at least give you partial credit if there's something there. Okay, fine. So this was the okay function, and somebody asked about go-tos. So 8 queens, 2D, go-tos. So he's going to give you, do we need to memorize this part of the code? The okay function? Yeah, I would highly suggest you memorize it. I can't guarantee that it's going to be on your midterm. He didn't show me an example. If we have time, yeah, I'll go over stable marriage. But I believe stable marriage uses the same okay function, just a little variation of it. But yeah, okay, fine. Let's do 8 queens. Let me just make sure I'm not missing anything here. So we did this. Yeah, I have stable marriage. Okay, we did that. And we're just about to do fill in the blank with 2D go-tos. So he'll give you the code. Okay? So is he just making us... So for the 8 queens, he's going to give you fill in the blanks, if I remember correctly. Okay, he's going to tell you fill in this blank. What is supposed to be written here? So let me see if I can find it. Where is it? Okay, for example, he'll write next column is going to be C++. If C equals 8, what happens? Then he's going to say next row. Next row will be R++. If row equals 8, what happens? And then he's going to say, what is he going to say? In backtrack, he's going to say C minus minus. if column equals -1, what happens? And then in print, he's gonna say for int I is less than 8, I plus, and then you do a nested loop for int 0, j is less than 8. And then you see out q of ij. We're gonna do, is it a space? We don't actually need to. Close that, we do a C out and del. And then we close that, and then it says what happens there, okay? After you finish the print. So let's work on this step by step. Does everybody know how the 8, if we just answer like this, will we get full credit? I'm not so sure what you mean, Yusra. If C equals 8, perfect. Go to print. Excellent. Now, he's on my midterm, he didn't ask why. He could ask why. The reason is all columns have a queen placed, so we can print. Now, again, if somebody doesn't know how 8 queens work, or you forgot, or you need a refresher, tell me in the chat and I can go over it. But if not, I'm assuming that because most of your assignments were on 8 queens, that you know how it works. Okay. If C equals -1, good. So, Joel, tell me how to say that in code. He's not gonna. That's the explanation. All solutions are found. So, what does that mean in code? First, second. Perfect. Go to backtrack. Good. This just means that we tested out all rows in a column. All. And couldn't place a queen. One D number 2. Nope, since the row is no, Chatteram, I don't remember any question having where you had to write like a program style. R equals 8 is backtrack. Okay, you guys want me to go over 8 queens? Okay, give me 1 sec. Okay. I'll go over that in a sec. If C equals -1, we went through every row. Good. So, meaning, I say what? What do I say here? In that box, what do I
Return
say?
0.
Excellent. Excellent. I found all possible solutions. This means all solutions found and the program. Okay, perfect. Return 0, and then the last one here for the print. This says I printed out this right here, prints out the board. This right here prints out the board. So what do I do after I printed out the board? Excellent. Go to backtrack. Good. Backtrack to find another solution. Okay, perfect. So, a couple of kids wanted me to go over 8 queens. So let's do that really quickly. Okay. This is okay, great. So now, can you go over still? Okay. I'm gonna try to. Okay, here's the print function that somebody asked for. Okay. So let's first explain what 8 queens is. So the idea of 8 queens is that we want to make sure that we can place 1 queen in each of the 8 columns. So 1 queen per column without there being a conflict. How do we define a conflict? We say no 2 queens are in the same row. No 2 queens are in the same diagonal space. So let me give you an example of diagonal spaces. This is a diagonal space. This is a diagonal space. Diagonal space, okay? Those are examples of diagonal spaces. And the tests will figure that out, but we're not going to go so much over the code. We're going to go over the practical thinking of it. So the code starts us off with placing a queen here. And queens are going to be represented by X. So I place a queen there. Great. What do? I go to next column. Okay, this is go to next column. I check. Can I place a queen here? No, it fails the row test. So can't place a queen there. I check. Can I place a queen here? No, it fails the up diagonal test. Can I place a queen here? Yeah, perfectly fine. Nothing else is in the rows and nothing is in the diagonals. Now remember, we don't really check to the right of the queen because nothing was, oh shoot, nothing was placed here yet. Nothing was placed in this portion of the board. So I only check to the left. Okay. Now I start doing the same thing. Can I place a queen here? No. Can I place a queen here? No. Here? No. Here? No. Here? Yes. Okay. Same idea. No here, but yes here for number 3, column 3. Column 4, I can in the first row, or in the second row, or in the third. I can in the fourth row. For the 5th column, I can in the first, second, third, fourth, or 5th row, but I can in the 6th row. For the 6th column, can't place one here or here. So let's go down them. I cannot place one there. So I place one at the end. Okay. Now, the only other place I can place a queen for column 7 is right there. I'm going to do it in black. Actually, red. So in red. What's the problem? It conflicts with a down diagonal queen, meaning this blue queen will come and eat this red queen, which we don't want. So what do we have to do? Somebody tell me in the chat, what do I have to do? Excellent. I have to backtrack, meaning I have to go back to the previous column and I have to reset everything to 0. So Backtrack tells me start at the top, right here, and go down. I go down, I look for my queen, and what do? I reset it to 0. That's what I do. Fifth row fails the diagonal test. Which diagonal test does the fifth row fail? Oh, you're right. The fifth row does fail the diagonal test. You're right. Yeah, you're right. Okay. Let's just assume that it doesn't for now. I just want to explain backtracking, but you are correct. It does fail the with place 0, 0. You're right. So you know what? Let me also change that really quickly. Okay. So then, you know what? Let's just redo this so it doesn't confuse anybody. So I go through row 6. Can I place a queen? No, 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 no. No, no, definitely no, and no. Okay, fine. So row 6, I can't place a queen. So I go to row 5 and I backtrack.
You mean column, right?
Column. Yes, thank you. Sorry. So I'm in column 5. And now backtrack says, go through the entire column, find the queen, and reset it to 0. So now that's an empty space. And what I do is I go to the next row. I go to next row and look for an empty spot that I can place a queen. So can I place a queen here? No, I can't. Good. Conflicts with that one. So, give me one sec. Good. So, I check this entire row. Now I'm on row equals 8. What does row equal 8 mean that I have to do? Backtrack again. Excellent. So I go to column 4 and I do the same thing. I check for my queen and I see it's in position in row number 3. Turn that into a 0. So that's empty now. Now I go down that row. Can I place one here? No. Can I place one here? No. Can I place one here? No. Can I place one here? And the last one? Yes. Okay. And then, now that I was able to place a queen in that column, I go to the next column. And I restart with that column. So, column 5. Can't place one here, or here, or here. Can I place one here? Yes. Right? No, I'm lying. I can't. Here, no. Here, also no. Here, no, and here, no. So that means that I have to backtrack twice now, because once I erase this, row equals 8, and I have to reset 3. So I have to look for the next place where I can put 1 in 3. So not there, not here, not here, not here, but here. Okay? And so that's what the computer is doing, just at a much faster speed. It's going through all possibilities where we can place one queen in each column without there being a conflict, meaning no 2 queens are in the same row and no 2 queens will diagonally attack each other. Okay? Hope that clarifies what 8 queens does and backtracking for whoever asked. Can you do backtrack as an if statement instead of a while loop? No, because the reason is you as a programmer don't know all 92 solutions by heart. And even if you did with the variations, you wouldn't know when the computer decides those 92 solutions. So you have to use a while loop because there isn't a standard amount of spaces you have to go through. Meaning I can have a queen in position 7-7, or I can have a queen in position 7-3. My if statement would have to be a fixed number of steps to go through, but a while loop uses true or false understanding. So if this is false, I keep going. If this is false, I keep going. False, true, I stop. I don't even have to keep going. So an if statement wouldn't work in this case. Okay. Any more questions? Okay. I'm going to assume no. So I'll let you guys pick. We can either do... Okay, I'll tell you what I remember was on my test. These two were on my test, but a lot of people wanted to do stable marriage. Do you guys want to do stable marriage or one of these two topics? Either pointers or pointers? Okay. Anybody else? Okay, okay, I'll do one. Fine, let's do it. Okay, so in your class packet, or your class notes rather, no, I'm not sure you wouldn't have stable marriage. It's very possible you can have it on your test, but it looks like we're running out a little bit of time. So I just want to make sure I cover whatever everybody else here wants. Okay, in my booklet, my class notes, it's page 43. It should be titled Understanding Arrays as Pointers, and it gives you a bunch of... It gives you something like, it uses the size of function. So it says int main, and then it says int b 2, and then it'll say C out size of b, and it'll say C out size of b plus 0. Then it'll say C out. Will you be back tomorrow? No, tomorrow there isn't a review session. Yeah, tomorrow there isn't a review session. The recording, again, it's on the... Let me put this one more time. QC. Okay. If you look up QC Learning Commons, it should be there. Waxman might be giving a review tomorrow. That could be it. But I'm not part of that review for Waxman. Size of... So this uses pointers in arrays, which I believe some people wanted. What else? 3 more. So this one has 8 parts to it, by the way. Okay. So I'm not sure when the recording is going to be posted. I'm going to follow up with Alan, who's in charge of the Learning Commons, and just have him post it later tonight. Because this is going straight to the cloud. So it's under his email. It's going straight to his email, the recording. I'm not sure what, Ariane, I'm not sure what the last topic you guys learned in class was. So I'm not sure if it's going to be on the midterm. Okay, so let's go over this. Here I have an array, right? I have a 3x2 array with different values, okay? Now, in computer hardware, the review with Waxman is tomorrow. He should have sent out an invite, but again, I'm not 100% sure when. Okay, so we, for our understandings, will draw 2D arrays in 2D format. We will draw rows and we will draw columns. The computer doesn't see it like that. Everything in the computer is just one line. Everything in the computer is just one line. Remember, arrays are contiguous, meaning there's no separation between them. So what I really do is good. So it's really just this array of 6 elements, but each one has a specific position. So this is going to be, for example, row 0. This one will be row 1. And this one will be row 2. Okay? Okay. So do you guys remember what the size of function does? Excellent. It gives you the bytes of a specific data type. So just to go over it with you guys, on the side, I'll do it here. Chars have a value of 1. Short have a value of 2. Ints have a value of 4. Longs, double, string, and addresses have a value of 8. Okay? Fine. So keep that in mind when we answer these questions. So I say size of B. Now, B. Do we need to know the size of anything other than ints and pointers? I would say no strings and addresses as well. I'm not sure what you'll have again on the test, but I didn't have one with specific bits. Okay, so B has how many integers? Six. No, it doesn't have 24. It doesn't have 2. It has 6 integers, right? We characterized B as an integer array with 1, 2, 3, 4, 5, 6 integers. Okay. Each integer, we said, is 4 bytes. So what I do is I do 6 times 4, 6 ints times 4 bytes per int equals 24. That's what's going to be printed out for the first one. Yes, bit size of address is also 8. Okay. So far, so good. Yes? Okay. The answer is 24. Correct. Just the number 24. Okay. So now with arrays, this portion is B plus 0. This portion is B plus 1. And this portion is B plus 2. Okay? So if I tell you, give me the size of B plus 0, essentially, it's the pointer pointing to the first row, which is 8. Excellent. Good. The next one, see out the size of, so B plus 0 is what? b plus 0 is a pointer, right? It's a pointer pointing to the first row. And we said pointers have a value of 8. Now I'm dereferencing that pointer. Okay, this right here means dereferencing. Dereferencing a pointer gives me what?
The value of the address?
No. It gives me the address, right? Because I'm dereferencing a pointer. If I was dereferencing an address, I would get the value at that address. Does that make sense? So, for example, say I have x. X is stored at 100, and x is sorry, no, that looks a little weird. X is stored at 100a, and it holds the value 5. Okay? If I say PTRX has the address of X, right? Correct? So, if I dereference the pointer, I get an address. Does that make sense?
Yes.
Perfect. So, good. Now, the value of an address, we said over here, is 8 as well. So here, because this is a pointer, and the whole thing after dereferencing just gives me an address, I get 8. Okay. Now, for the next part, he will give you a specific address. He has to, or else you can't answer these next 4 questions. He has to. He has to give you an address that goes right before here. Okay? And so in my case, he gave me 0012FF68 as the address for whatever reason. That means that if I say B is, and then what is B? B will just be the address at which the array starts. So it starts at 0012FF68. Okay? That one's not the hard part. The hard part is the second one. B plus 1 is, and then whatever B plus 1 actually is. Now the question is, where is B plus 1 in the array? Three and 4, excellent. We call it, that's the second row. Perfect. So B plus 1 is the second row of the array. So I'm essentially moving 2 integers or 8 bytes over, right? Good. Now, I don't know if anybody remembers, but what did I say addresses are measured in? Or, sorry, written in? In which form? Excellent, hexadecimal. 8 bytes is what we call in decimal. I cannot add hexadecimal with decimal. So what I have to do is I have to convert that 8 into hexadecimal. So, in hexadecimal, it just so happens to be the same number. It just so happens to be 8. So 8 in decimal is 8 in hexadecimal. But if I give you something like 11, well, actually, decimal doesn't have 11. If I give you something like, no, it should have 0 through 9. Yeah, it should have it. Okay. So what I do is I take 0012FF68 and I will add 8 to it. Do you guys know how to add hexadecimal numbers? It's something you learn in 240, but Professor Waxman, okay. So if you don't know how to, don't worry, because Professor, give me a second, I'm getting hexadecimal numbers chart. Professor Waxman will give you, let me see if I can put it in the chat. He'll give you this chart. Let's see if it works. Yeah. I put it in twice for some reason. He'll give you that chart, okay? Where you can add two different numbers and their intersection will be the value of adding in, and he gives us 2 on the midterm. At least he did for us. So if I want to add 8 and 8, I go to the column where it says 8 and I intersect it with the row at 8 and I see it's 10. Okay? So what I do is I put a 0 here. And I put a 1 here. And then I add 1 and 6 is 7 according to hex. Everything else is 0, so it stays the same. And this is my address. You want to show us how you give me 1 second. Let me see if I can. Let me see if I can show you how to use the table. Okay, I'm gonna just have to draw it out because I can't. Let me stop the screen quickly. Try to get it on my iPad. Numbers. Okay, let me reshare my screen. Should be. Tell me if you guys see my screen. Can you see it? Perfect. So if I want to add, say 8 and 8, I go to where 8 is here, I add, and I go to 8. Now I find their intersection. So 8 and 8 intersect over here at 10. So that means 8 plus 8 is 10. If I want to add 9 and D, for example, I go to 9, I go to D, and I find their intersection. 16. Okay? That's how you use this table. Does that make sense to everybody? Okay, excellent. Great. Sorry if that was a little confusing before, but hopefully that cleared it up. Okay, great. So he gives you that chart. He has to because your class is not really an adding binary and hexadecimal number. Okay, we're good. So that's what this one gives you. 0, 0, 1, 2, FF, 7, 0. Perfect. Ampersand B. What does that mean? What does ampersand B mean? No problem.
The address of the first element.
Good. The address of the, okay, good. So B means, when I say B, I mean the beginning of the array, which is also the first element, which is also the first row, beginning of the first row. So now, what's the address of B? Excellent. Perfect. It's the same exactly. They're the same address. The same thing. So ampersand b equals b, which equals b plus 0. Right? Because remember, b plus 0 is the first row. Beginning, this is also b. And ampersand b. They all mean the same thing. So in this case, 0, 0, 1, 2, FF, 6, 8. And many people freak out that they're different because he puts them, let's say this is part A and this is part C, they have to be different answers. And they psych themselves out. No, it's the exact same answer. And if he puts B is and then ampersand B, they're the same exact address. There's no difference between them. Okay, but now here, D. This last part over here, this means something different. Ampersand B plus 1. I'm going to tell you what it means. And then you guys will tell me the address. Ampersand B means I start at the address of B. And when I add 1, it means I add one entire array. I add one entire array, which means I go to the end of this array and I pretend like I'm starting at a new array. So essentially, how many bytes am I adding? Exactly, I'm adding 24. But wait, it's not 0012FF68 plus 24. Because remember, 24 is in decimal form. So I want to change 24 to hex form. And he didn't teach you how to do that. It's a little annoying. He didn't teach you how to do that. So let me see if I can. Okay. It's essentially just doing 24 divided by 16. And so at this point you have it goes in one time with a remainder of 8. Right? 16 one time with a remainder of 8. Yeah, that works. Okay, fine. Let me show you a different way that I learned it. I think this is a little bit easier, but you guys decide. You have a coefficient multiplied 16 by 0. Then you have a coefficient multiplying 16 by 1. And then a coefficient multiplying 16 by 2. So you first want to start with the biggest multiple of 16 that goes into this number. So 16 times 16 is 256. Thing is, 24 is not going to fit, so this is 0. Great, we ignore it. Now, I do this. I say, how many times does 16 go into 24? And we said once. And then I'm left with 8 left over. So can go in again. So 8 times 16 to the 0, which is just 1. No, this isn't 330. 331 is databases. Oh, if you're looking at the top of my screen, no, I'm just doing this in that notebook. Has nothing to do with databases. Let me see the questions. Hold on. Y16. Yeah, hexadecimal is base 16. 1 remainder 8. Perfect. Exactly 18. Okay, yeah. Perfect. So this is the same thing, 18. So you guys decide which one's easier for you guys. If you want, there are a million YouTube videos on how to watch it if you want more practices. That's it. So 18. Okay, so you have 18 in hex now. So for this last one, we do 0, 0, 1, 2, FF, 6, 8, plus 1, 8. Remember, this is in hex. We have to convert it to hex. We can't do plus 24, or you're going to get the wrong answer. And I'll show you. You know what we'll do? Just for that sake, we'll do plus 24. So let's see. 8 plus 8. So we established what 8 plus 8 was before. Should be 10. So we have 0, 1. 6 plus 1 is 7, plus 1 is 8, and then everything else stays the same. So the answer for this, 0012 FF80. But let's say we did plus 24. So 8 plus 4, 8 and 4 is C. 6 and 2 is 8, right? 6 and 2 is 8. Then everything else stays the same. This is not the same thing as that. Okay? So if you make that mistake, the entire question is wrong. Meaning that entire part, this entire part is wrong. Okay? Now, this should be this page, or something similar to this page, should be in your notes. Okay? He almost copies and pastes the entire thing, just changes the value of the address that I gave you over here in black, and he'll change the value of this. But he really asks almost the same things. Size of, size of, size of, and then he'll say b is, b plus 1 is, ampersand b plus 1. Why is it plus 24 and not plus 16? We have 6 integers. Each integer is 4 bytes. So we add 24, not 16. Do you have enough time to review the last topic quickly? What is the last topic? No. For a series of questions like this, if one is wrong, only that one is wrong. But, for example, if you get this correct, and you get this one incorrect for whatever reason, you get it, it's just copying. But if you get it incorrect, then it'll affect your answers for the rest. It's going to be a domino effect, meaning inherently the rest will be incorrect, because if you add 4 bits to the wrong address, you're still going to get the wrong address. So you can't put you can't put that. That would be the wrong answer. Tiana, does he has to explain? Okay, for this one, I think he does actually ask you to explain some of them. So something like this one, when I'm circling it, he won't ask you to explain that, but something like what I'm putting in a box right now, something like this, he probably will ask you to explain. Do you have enough time to review the last topic quickly? Sorry, which topic was that? The brute force one. Okay, fine. Let me just. Okay. Fine. You guys want to do brute force or stable marriage? I'm gonna take. Can I put a poll in here? I don't know. I don't think I can, but okay. Let me know if you guys want. Let's see, brute force. Brute force would actually be 8D, not 1 or 2D. Let me just. Okay, I'm getting a lot of brute forces. Oh no, wait, I didn't check the top. Hold on. Wait, stable marriage. So, Leo, the array would be 8D. It would be 8 dimensions. That's the idea of brute force. You would have 8 to the 8 times that the loop would be going to just try to find the specific. Here, one sec. Creating a poll during a meeting. Okay, for some reason I really can't do a poll, so let me just count it. Okay, for stable marriage, I have 1, 2, 3, 4, 6, 7, 8. And then for brute force, I have 1, 2, 3, 4, 5, 6, and 8. Okay, it's actually tied. But oh wait, no, Vanessa just answered. Okay, so it's 9. So I'll do the brute force. And then if I have time, I'll do stable marriage. But so again, stable marriage wasn't on my exam, which I took spring of 2020. I think it was 2023. I think it was 2023. Yeah, it was 2023. And then it wasn't in the fall of 2023 either. I'm trying to think if it was in spring 20. I can't remember it being in spring of 2024 either. But I'll still go over it just in case. But the brute force, there was one question that came to mind while we were talking about this, which is why I was just trying to remember it. He asks you for specific combinations. So for example, I'll give you something like this. I'll write it down. Okay. We'll say this. Okay. We'll say int count equals 0, int q sub 8. One sec, let me see if I can get it from my doc. Then I'll screen share it for you guys. Does anybody have a specific question about it, or you guys just want to brute force, or you guys just want to go over the entire thing? Everything. Okay, no problem. Let me just get it. I'll screenshot it, and then we can. Here it is. Okay. Okay, this is from my notes, so it might be a little bit messy, but that's what it is. Okay, tell me if you guys can see my screen again. Yes, if he gives you stable marriage, you should get the data set, theoretically speaking. Okay, fine. So here is, everything is just my notes, but the only thing he did actually put brute force on the test. The only thing I can remember him putting is, okay, let's just go over this really quickly so you guys have an understanding. Brute force one, two, three, four, five, six, seven, 8. Okay. It tries each and every single one of the 1, 2, 3, 4, 5, 6, 7. It tries each and every single one of the possibilities between 0, 0, 0, 0, 0, 0, 0, 0, and 7, 7, 7, 7, 7, 7, 7, 7. It tries every single possibility in between, and it uses the OK function 8 to the 8 times. So you can see that this is an extremely inefficient way of writing a code, okay? He calls it, and I think I labeled it here, dumb 8 queens, okay? Just in case if you see it on the test, he calls it the dumb 8 queens. We do not have to, no, so you don't have to write the whole code. What he's going to ask you, and I'm going to put the question a little further down after I explain it, he's going to ask you, first of all, how many counts are there if he decides to put one in, and you have to know the difference between pre-incrementing and post-incrementing, which I hope you learned in 111. And then he's going to say, what the count would be for a specific number. So I'll explain that in a second. Okay. So this first for loop deals with this. This is I0. This is I1. That's I1. This is I2. I3, I4, I5, I6, I7. And the same idea goes down, okay? They each deal with one spot in the array. Oh, so I think somebody was asking. I think Leo might have been asking. It is a 1D array consideration, but there are 8 portions to it, meaning the for loop makes it 8. Oh, the dummy one, yes. We don't know. You don't. Good. I++ is post increment. Plus I is pre. Okay, fine. So he'll give you this portion and he'll just say, okay, so you run through the code. It goes through. So this is going to be 0, and then 0, 0, 0, 0, 0, 0, and then we change it to 1, and then we change it to 2, to 3, to 4, to 5, to 6. Okay, it's 7. We reset everything here to 0. This turns to a 1. Then we do 1, 1, 1, 2, right? Then we do 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. Reset everything. This becomes 2. 2, 1, 2, 2, 2, 3. Okay, just like the odometer that you guys should have done. Okay, so the odometer just had 6 portions, and this one has 8. Okay, so far so good? I hope so. Now, if he's going to ask you this. Okay. He's going to give you this portion on the midterm. If he gives you this question. He's going to give you this portion on the midterm that I'm putting in a box right now. He's going to give you that portion on the midterm. Then he's going to say, let me just erase this, a little bit of it. He's going to say this. If OK of Q, print Q, comma, plus, plus count. And he has to tell you what count starts at, so I'll do that too. I'll just say count starts at 0. Okay. So, and he's going to put that line right there. Okay. And he's going to ask you 2 questions. One, what happens if I don't put this line? What happens? Excellent. It doesn't check if it's valid or not. And then what do I get that's printed out? No, I get a lot, actually. You get everything. You get not infinite solutions. You get 8 to the 8 solutions, which is a lot. You get 0, 0, all zeros, then all zeros and a 1, all zeros and a 2, all zeros and a 3, and a 4, and a 5, and a 6, and a 7, up until everything is 7. Okay? Everything inclusive of non-solutions, actually. It's not just 92 of them. So if I keep that out, I get every single thing to be a solution. So let's just try it out with something that's 3 to the 3. Okay, 3 to the 3 is going to be a little easier. So say I start at 0, 0, 0, and the last one can only be 2, 2, 2. So 3 to the 3 is 3, not 27 choices. Okay, it just so happened that this was on my exam. I didn't have to do 8 to the 8. I did 3 to the 3. So it's 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. Oh, wait, no, I made a mistake. Sorry. Okay. 0, 0, 2, 0, 1, 0, 0, 1, 1, 0, 1, 2. Then I do 0, 2, 0, 0, 2, 1, 0, 2, 2. Then I do 1, 0, 0, 1, 0, 1, 1, 0, 2. I do 1, 1, 0, 1, 1, 1, 1, 1, 2. 1, 2, 0, 1, 2, 1, 1, 2, 2. 2, 0, 0, 2, 0, 1, 2, 0, 2. Then I do 2, 1, 0, 2, 1, 1, 2, 1, 2. 2, 2, 0, 2, 2, 1, 2, 2, 2. And let's just make sure this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Excellent. This is all 27 possible choices. And so all of these choices would be printed out if I did not put that if statement. If I did put the if statement, we'd only have the answers that are correct. Okay, that would pass the if statement. But now I have a count. Okay, I have a count. Remember that. He says this, and so this is the important part. I have a count. So his question would say, and you know what? We'll use this. We'll use this example. We'll say, what will be the configuration when the value of count is, sorry, yeah, the value of count printed is, and we'll say 24. Okay, now remember, the value cannot be bigger than the amount of possibilities. So if, and he made a mistake on one midterm one year, if instead of saying 24, he says 300, that's not possible. Okay, there are only 27. It can only go up until 27, nothing more than it. So if he says 29, you raise your hand and tell him, Professor, I think there's a mistake. He looks at it, he says, yeah, change the number to, and then he'll give you a number to change it to. Okay, but he does make a couple of mistakes on the final, excuse me, on his test. So if you think so, just raise your hand and say it. Okay, so the question is what? Now remember, the count starts at 0, and here we pre-increment. So we pre-increment, say plus count. So this is count equals 0, count equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Boom. My configuration will be 220. So technically, if we don't tell him, no. I also wouldn't take that risk because somebody else might say it to him, both in your class and the other class, because I think he splits you guys up into Remsen 100 and 101, if I'm not mistaken, because everybody takes it at the same time. Okay, so that would be the configuration. But the question is, if I give you 8 to the 8 possible choices, are you going to sit there and count 8 to the 8? The answer is no. What you're going to do is, this is just a hidden version of converting. Okay, you're converting into, in this case, it is into base 3. You're converting into base 3. How do you know? There are only 3 places, so it's base 3. If there were 8 places, it's base 8. So now, you take 24, and you continuously divide it by 3, right? Is that how you do it? Hold on. Count is 3. 0, 0, 0, 0, 0, 1, 0, 0, 0. Yeah, it should. Which gets me 8, remainder 0. Then I do 8 divided by 3 again. That should give me 2, remainder 2. Then 2 divided by 3 gets me 2, remainder 0. And then I read it up. So I have 2, 2, 0. And that's how I get this number. You read it up, by the way. Okay? Does everybody understand that? Or again, you can do how I showed you before. 3 to the 3. Some coefficient multiplied by 3 to the 3. Some coefficient multiplied by 3 to the 2. Some coefficient multiplied by 3 to the 1. And then some coefficient multiplied by 3 to the 0. Okay, and we start with the biggest. So 24 doesn't go into 27, so this is 0. 3 to the 3 is 9. 9 goes into 24 twice, 18. And then I have remainder 6. 3 goes into it twice, and then nothing at the end. Is it? Yes, you're right. You are correct. You are correct. Sorry, I made a mistake. What did you say? You said 0, 2. Good. Sorry. Good. Sorry about that. Okay, good. So you have 2, 2, 0, both the ways you look at it. So whichever way is easier for you. And again, this is just part of converting bases. That's what the topic is called. In this case, count, because it's an int, it's an integer. This is decimal. And this is base 3. So because it's only 3 positions, 1, 2, 3. But one of the most important parts is understanding how the count works. Okay? So, for example, if the count is pre-incremented, it's good. It works how it normally would. If the count is post-incremented, though, that's where it's important. Okay? If I do count plus plus, the answer is going to be different. It's not going to be this one anymore. Okay, let me show you in the picture what it's going to be, and then I'll show you how to convert it as well. So if I want the count of 24, I want the count of 24. This is going to be, we start at 0. Did I mix them up? Did I do, I think I did post increment. Hold on. This one is for pre or post increment. Count is 0. This is count. No, yeah, sorry. This is for post increment. This, what I just gave you, is for post increment. For pre increment, which means count. With pre increment, let me show you what that looks like. With pre increment, I increment count first. So count becomes 1. So this is count 1. This is 2. This is 3. This is 4. This is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24. 2, 1, 2 now. Okay? So, how do we know to use pre? He'll give it to you in the question. So, like how I gave it to you here, pre-incremented, post-incremented, he will give it to you in the question. And then he'll ask you also to write the OK function, which is the exact same thing we did as before. So there's nothing for you to worry about there. Okay, fine. Nothing for you to worry about there. The only thing that you would do is in binary, you would get 2, 2, 0, and you would subtract 1 from it. But now, the same, yes, correct. With the row test and the absolute value of, I think it was Q sub I minus Q sub C equals C minus I, right? Something like, where is it? This. Okay. So with this one, give me one sec. With this one, you would be doing 220 minus 1. And the thing is, this won't give you 219. Remember, that's not possible. Okay? Because there's no 9. The numbers only go up to 2. Remember, we never had a 9 here. In the green, we never had a 9. So what it says, is, so the OK function is the same as what we wrote before. I can scroll up to it in a second and you can either take a picture or screenshot, but let me just finish this. The -1 here means go back to the previous position. So if I'm at 220 now, the previous position was 212. Okay, previous. And we can go back up and see it over here. 220, previous was 212. How do you know how to do this? Instead of treating this as a 10, treat this as, instead of treating this as decimal, treat it as base 3. Has he done? Yes, he has done pre. I think my test was pre-increment, which is what got most kids. They gave the post-increment instead of the pre-increment. And this is worth, I think, 5 or 10 points. So it's and this is one of the questions where the answer doesn't matter. The answer does matter. The explanation matters a little less, because if you can explain this one, because this one you can explain correctly just by understanding what pre and post increment means. The configuration, he wants to see that you actually understood it. I know it's a little, yeah, but it's fine. Okay, so this one, instead of treating this as a 9, treat this as a 2. So I cancel this, and now it becomes, what is that? 3. Sorry, treat this as a 3 because it's base 3, not base 10, right? Usually we would do 220, and change that to a 10. And our neighbor, we take 1 down. So now we have to change it into its base. It's base 3, and this one goes down. 213 minus 1 is 212. Okay, that one's a little bit complicated part, but I do suggest that if he gives you 3 to the 3 or 2 to the 2, he won't give you 2 to the 2, but if he gives you 3 to the 3, 4 to the 4 is what? Is that 64? 4 times 4 is 16 times 4 is 64. No, it's higher. It should be 256. Yeah, it's 256. Okay, never mind. Don't do that one. Do you get the whole thing wrong if you get the explanation? I don't think you would get the whole thing wrong. I think the answer is worth 3 points and the explanation is worth 2 points, or vice versa. Does that make sense? Okay. Give me just 1 second. Mike, can you send the feedback form again, please, if you still have it? Thank you. Okay. So, each question depends on the different amount of points. Again, 15 questions. I think the highest score you can get is like 150 or 165 or 155. I forget. But that's the highest. I do suggest you try every single question before you leave the midterm. I know sometimes it can get to being a little boring, but still. And if you guys want a final review session, I would really recommend you guys fill out the feedback form just so that the Learning Commons knows that we have a lot of attendance at these forums and how we're doing, then I can host a final review session as well. Yeah, once we get all that feedback back and we can get the funding for it, I'll be more than happy to do either a 2/3 hour final review session during finals week, so it's as close to the midterm as possible. It's just the final as possible, excuse me. But they need to know that people actually want to come to these. So I'll put it in again. And let me answer some of the last questions. I don't have any of the links. Guidance on topics, really study what you learned in class, mainly focus on what we reviewed today, because those are, from what I remember, there's a little variance from midterm to midterm. Correct. Answer as many as you can. You don't have to answer 10 out of 15. I also don't know if they're going to be 15. It could be 12 questions. Answer as many as you can, okay? Right. I would say start with the easy ones, because like easy ones will accumulate to 60 points. 60 points around, yeah. In-person research like this during free hour. It's not strictly on Zoom. Theoretically, I could do. Nobody ever asked me to do it in person, but if you guys really want it in person, I suggest putting it in the form, and we can get a room request. We do have to get like a bigger lecture hall, just in case, but we could. I could theoretically do it if you guys are down for it. Do we need to fill in anything in the main? No, from what I remember, no. Again, but he could. I just want to tell you, this is everything I'm telling you is from my midterm. He could have changed it for yours. Okay, if you think it's better in Zoom/in person, completely up to you. But put it in the form. If enough people say they want in person, we could do both. Honestly, we could do an in-person Zoom as well, and we'll just have a couple more people looking at the Zoom, asking me if I have questions. What will the answer be for this? Yeah, of course. Let's see. Please, what will be the answer for this? Char star. So remember, char we said was a value of 6. My laptop, my thing. So so this is just an array with 6 characters, right? It's 2 rows and 3 columns, and it's like A, B, C, right? Each char is worth 1 byte. We have 6 of them. So if I ask for the size of it, it's going to be 6 times 1, which is just 6 bytes. But 6 is the only thing that's printed. The size of function will only print out a number. So 6 in this case. Is going through this Zoom enough? I would say try doing another hour of studying. If you really don't have the time, then and this was the best you could do, that's fine for resources for the midterm. But again, I just gave you everything that I remember from my midterm. If he didn't change it, then you get lucky. If he did change it, then I would suggest just studying a little bit more. Imagine we still have a lab quiz right now. I've said we are taking it later after the midterm for marriage. So yeah, we didn't have time to go over stable marriage. I know Waxman has his review session tomorrow. I would suggest asking him for stable marriage. The midterm for marriage. Does anyone have the answer for the cross lab for the Asian woman? Okay. So somebody just asked me. It's an on-campus job. What I do is an on-campus job as a tutor. But I volunteer to work on the weekends, meaning I still get paid, but I volunteer to do it outside of my working hours. I'm gonna answer you the same points. I don't have that. I'm a Queens College student, Learning Commons tutor. The quiz for Lily's class. Thank you. Can you scroll up a little where it gives the solutions? I'm assuming you mean this part. Tell me if you want me to go a little higher. Okay, no problem. I'm going to stop the recording here, but feel free to ask. Yeah, the review is done. And I will send this to, well, it's going to Alan straight, so he's going to be able to link it either tonight or tomorrow, but let me give you guys an email to email just in case. No problem, Mike. Let me see if I have the email. I don't have it. Okay. No, I don't think I'm going to be posting the notes just because they're messy and you can see them on the Zoom if you have any question. Links to guidance of stable marriage. I don't personally, but I can review that topic for the final if you really want. I'll just put in the feedback form that you want 3 hours and we'll see what we can do. Do you have any solution? No, you have to know the solutions. Those won't be given to you. Or at least you have to know how to find the solutions. I'll bite the bullet of stable marriage on return. Where they go? No, it should be. Yeah, I think you have lecture in Remsen. If you have lecture in Remsen, then pointer is 8. If you have lecture in Remsen, then yes, it's in the same place. Okay, I'm gonna stop the meeting.